Good morning, everyone. This is not the typical webinar that John normally does. John and I don't get a lot of time to just sit down and talk about deeper conversations. So John also does a lot of podcasts where he gets to ask a lot of people questions. And if you've not been listening to those podcasts, certainly go to regenerativeagriculturepodcast.com and check that out, because there's lots of information there. So John, I am very glad to have this opportunity to have this dialogue, and I'm also blessed to have a company like yours to work for. Very privileged to be a part of your team. It really, truly has been a blessing.
Thanks, David. I've been looking forward to this conversation. The headline that's flashing in front of my eyes right now says, "Brace for impact." Here comes David.
Brace for impact. Good. So you're ready? All right, good.
I'll just comment that I really have enjoyed working with David. He was one of the first consultants that joined the AEA team, and we do have a lot of fun, and we have a lot of intriguing conversations, and that we wanted to share more with you.
Excellent. So John, my first question for you is, why are you so passionate about regenerating soils and food production?
You mean I should be passionate about hunting and fishing and boating and stuff like that instead?
I'm saying you could be. I'm wondering why you've chosen to make regenerating the soil and food production your passion.
I think there were two pieces that led me to be really interested in agronomy and plant nutrition. The first was that we had honeybees on our farm, and I still remember my dad taking me out to help inspect the honeybee colonies when I was perhaps 9 or 10 years old for the first time. And I was deathly afraid. I was really scared of being around those stinging insects. But after doing it for the second or third time, when you slow down and you're not in a rush, you're not in a hurry, you take the time to really connect with the honeybee colony, with the work that you're doing, all of a sudden it's as if though there's this shift in consciousness and you're in a different space. You're really connected and you become completely calm. Fear completely disappears. It was a really amazing experience, almost a spiritual experience. And I very quickly came to the point where I was not afraid of the honeybees at all. They were not afraid of me. I would go out to take care of the bees without, I would wear a veil because I didn't want to get stung in the eyes or in the face. I would go work with the bees in short sleeve shirts, and I really enjoyed it. So I became aware of this connection, and through my early mid-teens, my dream was actually to be a full-time beekeeper. When I grew up, I never anticipated getting into agronomy. But then through the experiences we had on the farm and working with crops, I had the responsibility of working with the drip irrigation and foliar applications. I also realized that I could have that same connection with plants as I could have with honeybees, and really feel the energy and feel what was happening with the crop. That perhaps certainly was based on visual observation, but it was also based on an intuitive sense of what was happening, what's going on in the field. And I found that that is something that is shared by many growers and many farmers, is really a sense of what's happening with their crops, what's happening with their livestock, that may or may not be directly visible to the eyes. Then from that, when I founded Advancing Eco-Agriculture, started doing consulting work, and the reason I'm so passionate about regenerative agriculture today is when I realized that we can grow plants that are resistant to diseases and insects and eliminate the need for pesticides, and that those healthy plants produce food as medicine, and at the same time, we sequester tremendous amounts of carbon, we build soil organic matter, we build soil health, and we regenerate soils. And so I also started learning a lot about the mechanisms and the modes of action of various pesticides, how they work to kill pests, how they influence plants, how they influence soil biology, and also how they influence us. And I became really passionate about the potential that regenerative agriculture has to completely regenerate ecosystems, the environment, regenerate topsoil. When we think about all the challenges globally on our planet with intense floods, polluted groundwater, all types of plastics and pesticide and chemical pollutions, the reality is that regenerative agriculture, to a large degree, is the solution for many of these challenges, if not all of them. The awareness of the global implications for what regenerative agriculture can achieve and can contribute to the planet is why I'm so passionate about having it become mainstream.
Very good. My next question for you, as you look at why you're passionate and you consider all of this, if you were able to dictate regeneration of soils worldwide, what would you do for 10 years?
My goodness, David. So I think, where did you come up with these questions? Were you having nightmares or something? I think, so first of all, we have to understand that change doesn't happen in the field. Change happens between the ears. And also recognizing that growers and farmers do desire to do a good job. They desire to grow healthy food, and they desire to leave the land and the farm better for the next generation. So I think it's not a question of farmers' desire. It's a question of where are the incentives placed for growers. Right now, the incentives are purely on mass volume production. I'm not even going to use the word yield, but purely on volume of production with no consideration for quality. And there's no consideration for the rest of the ecosystem. Agriculture has many externalized costs because of groundwater pollution and everything else that is attributed to excessive fertilization, etc. So I would ask the question, what can we do to give all growers globally a desire to change the way they are farming? And I think a part of the answer to that question is they need to be compensated for producing quality, not just volume, not just mass. And if that were the case, they would absolutely begin doing that right away. And I think growers also need to be compensated for ecosystem services, sequestering carbon, maintaining clean groundwater, maintaining an ecosystem, maintaining an ecology, protecting insects and wildlife and bird populations and so forth. And you achieve what you incentivize, so compensating growers for achieving those things. And then the other aspect to that is beginning to systematically use a bit of a stick as well in reducing the permissible levels of pesticides in and on the food supply, reducing the permissible level of synthetic fertilizers such as nitrogen and phosphorus, and also offering very strong incentives in that manner to lead growers and researchers to develop systems that are not dependent on those inputs. And within all of this, to the best of my knowledge, I don't believe we even have a national food policy in the US. And I'm just speaking as one country, and your question is really global. But if we wanted each region of the world to have its own food sovereignty to the extent possible, would we really consider it appropriate to import 45% of our fruits and vegetables into the country? So I would also strongly incentivize regionalized and localized production as much as possible. I understand we're not going to produce avocados and pineapples and citrus in much of North America. But to the degree possible, I think we should regionalize and develop climate resilience in our agriculture as much as possible. So it's a big question, David, and a big answer. So the bottom line I would suggest is it is not that growers are resistant to regenerative agriculture. It's that they're unfamiliar with it. They may not understand how to do it. They may not have the know-how, but it's not a lack of desire. It's a lack of know-how and the fact that the entire educational process around agriculture for the last 7 decades has focused on green revolution style agriculture.
Change happens between the ears, as you say, and I think a lot of that is maybe just because people don't know. And so how do you see the importance of educating the consumer? I'm reflecting back on the book I'm reading currently, or rereading, called Silent Spring, and what Rachel Carson put out there, and how many people consume food that they don't know, and if they knew, which is between the ears. So what do you see on the consumer side, and how would you approach, how would you approach that incentive from the consumer side?
Oh, David, that's such an intriguing question. It's also one that I've thought a lot about, and I don't actually have a clearly formed opinion. Charlie Munger says that in order to be qualified to have an opinion, you need to be able to articulate the opposing viewpoint better than the opposition. So I'm kind of two minds on this one. The common refrain is that consumers drive change, that we need to vote with our dollars. And there is certainly an element of that we can observe to be true. We see that General Mills has made a commitment to do 1 million acres of regenerative agriculture by 2030. and more large-scale, Danone has made a commitment to regenerative agriculture. There are more and more large-scale agribusiness firms which are making a commitment to regenerative agriculture. And of course, we have to wait and see and learn what that all means. And so you could argue that that change is being driven by the desire from consumers, and I'm certain that that is partially true. And on the other hand, the majority of consumers in the US are very happy to eat at McDonald's and to consume fast food, to consume junk food, and buy very high calorie, high sugar junk food at the grocery store, processed foods rather than fruits and vegetables. And that is partially an issue of economics. It's partially an issue of education. And so the question is, can education with the consumers really have an impact? Yes, to a degree, but I don't think it'll change the entire food system on its own. And part of my reason for saying that is because I forget the statistics right now, but it's a significant majority. I want to say it's like 70 or 80% of adults never read a book after they graduate from either high school or college. So how do you educate a public which has no desire for self-improvement and for self-learning? And perhaps to some degree, they're very comfortable just going with the flow and doing what everybody else does. So, of course, you could make the argument that you need to then shift the status quo and change what everybody else does. So I think, yes, we do need to try to educate consumers as much as possible. But to the earlier question that you asked, I don't think that would produce the change that I desire to see in the world inside of a decade. It's important. It's a very important part of the process. But more directed than that, you just go straight to the source. You change agriculture directly. Don't try to do it indirectly through consumer demand. Do it directly through incentivizing the outcomes that you want to achieve.
You mentioned economics can be a factor for some people on the choices they make. They're choosing a quality food is difficult. And the thought that came to my mind is thinking about how much what we call healthcare today, which really is sick care, if those economics were transferred to help people eat a healthier diet.
Or even more simply than that, on a federal policy level, if we were to transfer some of the billions, even trillions of dollars that are currently government funding for the sick care system, as you described it, if we were simply to transfer that to producing healthy, high quality food, I actually had a conversation recently with someone who did the math on this and did a bunch of scenario outlining, and he described that we could produce all the healthy, high quality food that we needed to feed people economically and reduce the healthcare costs by approximately 60% and save money in the process on a federal level.
Wow.
The transition from using very intense fertilizer and pesticide applications and genetically modified crops to a more regenerative approach is not something that happens overnight. It is a conversion process that comes with experience. Agriculture and farming, is we know, is extremely risky. There's a lot of climactic risk. Every crop we plant, there's hundreds of things that could conceivably go wrong. And so because agriculture and food production generally is barely profitable, growers are being squeezed both on the supplies end and on the sales end. They're the first person that needs to pay and the last person that gets paid. And so I think there's an inherent aversion to exposing yourself to risk, which is a trait of self-preservation and something that farmers are certainly very cognizant of and need to be in order to be successful and to remain successful, at least have needed to be for the last 80 to 90 years with the economic policies and agricultural policies that we've had in this country of cheap food. So I think there is part of that inherent piece that comes with the domain, with the landscape. And then there is also simply that fear of the unknown, that if all of this science about regenerative agriculture and the science about disease and insect resistance and managing plant nutrition, if this were all true, then why haven't we been told about it? If this is all true, why aren't the universities teaching it? If this is all true, why isn't everybody doing it? And so those are questions that get asked very, very frequently. I think the answer to all of those questions is the same, and it's very simple. The question is that the economic incentives, again, you achieve what you incentivize, the economic incentives for the universities, for the agricultural input companies are not aligned with promoting that type of information. Because when you develop these regenerative agriculture ecosystems, your requirements for inputs drops dramatically and eventually completely disappears in some environments. And your use of ag pesticides will gradually disappear. So we have to follow the money. And you will see that there aren't economic incentives for a lot of this information to be widely publicized, even though it is very well researched and very well documented. It's not new information. It really is out there, but it's not publicized because there are no economic incentives to publicize it.
What is it that draws people into farming when there's so much risk? It almost seems like, there's some calling, there's some deeper level of commitment that goes with it.
I believe there is. There is a soul level sense of calling there, and it's, I think, from many people, desire to be connected to life, to be connected to living processes. And so I think there is an inherent desire within many people who feel called to agriculture and called to farming, that desire to be connected with life and with living processes and to create a new reality.
Makes sense. Makes perfect sense. All right. The next question, John, is what do you see as the most urgent/important step that a food producer must focus on at this time in the near future in order to be in business, to be a successful farmer in the next decade?
That's a good question, David. Speaking to that question from an agronomic perspective, I would say that there are two pieces that I would point out. The first is we need to stop spending money that is not bringing us returns. And the immediate reaction for it, most growers to that comment would be that, well, we're not doing that now. I don't understand where I could cut costs any harder than I'm already cutting them. I'm already trying to save money and be as conservative as possible so that I can remain profitable and not even, in some cases, just break even and stay in business. And yet, when we start, as you know, when we start working with growers, we start using SAP analysis, we consistently find that many growers strongly over-apply some fertilizers, particularly nitrogen and potassium. And I spoke at a webinar a few weeks ago with the Tineo team where I let my thoughts be quite clearly known about nitrogen. But it is a waste of money for growers to apply nitrogen the way that many people do, putting on nitrogen applications in the fall. It's not economical. It doesn't make agronomic sense. It doesn't make economic sense. And it is simply throwing away money. And so I think one of the pieces is that growers need to be smarter about how they spend costs agronomically, how they spend money on fertilizers in the future in order to be profitable and also to have a more positive impact on the environment. And the second piece, I would say, for the next decade and even past the next decade, growers need to we need to develop more climate resilient farms. We need to develop soils that can store and hold a lot of water, that can be drought proofed, that can be excess of waterproof to the degree that is possible. I mean, certain there are, as we experienced this spring in the Midwest, there are going to be climatic extremes that we may not be able to develop resilience for, but we should expect and anticipate that the climate is going to become increasingly variable, with increasing extremes becoming much more common, and we need to develop resilience in our ecosystems as much as possible if we want to remain viable for the long term.
And maybe that is what your answer will be to this next question, but maybe you have another thought, which is, what are some mistakes that you have observed being made or that have been made in the agriculture community or by individual farmers?
I think the single number one mistake that is most commonly made by many growers, not by all, but by many growers, it's that they don't measure. We try different agronomic things. We try this product, we try that product, and we look at it and say, oh, I can't see any difference. Or oh, I think it looks like it's a couple inches taller. And we use that assessment to make decisions about what we're going to do next year.
I would agree with that. Again, your answer surprises me, but yes, I agree with that. And I can understand it from a gardening perspective. I hate to not spray part of it so I can see the difference because I trust it's going to work. But when you are trying something, be sure to measure. Absolutely.
If it's not worth measuring, it's not worth trying.
All right, we're going to open it here for a couple minutes of Q&A. Got a question here for you, John, from Andy Harper. As a farmer in Alaska, where our soils are cold and biologically are slow moving unless there are raised beds and adding 60-degree water to make the environment suitable, how can regenerative agriculture be profitable in the northernmost regions?
That's a question that I don't really have the context and the understanding to be able to answer well, because I'm not intimately familiar with Alaskan agriculture. So I would say that the obvious question that I don't know the answer to is non-regenerative agriculture commercially viable and economical in Alaska? And if the answer is yes, then I absolutely believe that regenerative agriculture can be even more profitable than non-regenerative agriculture. So again, with the caveat that I don't know the full context and the story that is behind that, I know for certain that we can achieve even faster plant growth with very microbially active soils than we can with chemistry fertilizers and salt-based fertilizers. We can get even faster plant growth, healthier plant growth, and higher and more nutritious plant growth, more nutritious food. So if agriculture in Alaska can be economically viable using chemistry fertilizers, it can be even more so using regenerative agriculture systems.
Also a question from Greg Pinheiro. Thank you for the question, Greg. I agree with the approach of primarily incentivizing the agriculture industry as opposed to relying push through with the consumer demand. The sheer economics of the increased percentage of GDP that is going to increase healthcare and climate change degradation to fundamental infrastructure is going to create investment opportunities in real asset development as offered by regenerative agriculture. I teach agriculture at a community college and at several high schools, and wanted to give an encouraging word to the young generation who are realizing that what bad situation they have inherited and have better BS detectors than most. As an example, of our local high school has recently started a regenerative agriculture club. John, how do you see the integrated message of regenerative agriculture changing over the time you have been consulting?
That is a great question, Greg. And I first started using the word regenerative agriculture approximately 2006 or 7. And I certainly don't believe I was the first to use it. I think it's been around for 30 years or so, but it certainly has not been popularized and wasn't mainstream. To the best of my awareness, I was one of the first people to begin speaking about it on a wide level. And it was a bit of feeling like a voice crying in the wilderness for the first several years. But then around 5 years ago, it started becoming very popular in the group of people that I was having conversations with. And I would say within the last 3 years, it has begun approaching the mainstream. It's now a very common word. So the awareness of quote unquote regenerative agriculture has certainly shifted dramatically in recent years, just in the last 3 to 5 year period. But to your question specifically, Greg, you say, how do you see the integrated message of regenerative agriculture changing? There is still no consensus on what regenerative agriculture really is and what it really means. There's a strong emphasis on carbon sequestration and building soil organic matter, building soil health. I think that component is relatively well understood. But the additional components of being able to produce nutrient-dense food and nutritious food as medicine, and being able to produce crops that are resistant to diseases and insects and eliminate pesticides, has not yet been well understood, even by the broader regenerative agriculture audience. So when we think about that integration and the integrated agronomic approach that is needed to bring that happen, the awareness is growing, it's shifting, but it's still early days for that. It hasn't reached the mainstream yet, even though it's a conversation that I continue to try to have with people and expand.
And another question from Jeffrey on that. There are many definitions out there regarding regenerative agriculture. Can you define this in your terms and perhaps contrast it with other definitions that are out there?
here's what the term regenerative agriculture means to me. It means a combination of three goals are being met. Goal number one is that we're producing plants that are so healthy they're resistant to diseases and insects. Number two, when you have plants that have that level of health, you're also producing nutritious food that is food as medicine, extremely high quality, doesn't spoil, doesn't rot, doesn't degrade in storage, or not nearly at the same speed, depending on which crop you're talking about. Number three, you regenerate soil health at the same time you are growing a crop, not separately from growing a crop, not you grow a crop and degrade soil as part one, and then as part two, you grow a cover crop and you sequester carbon. But you need to have an agriculture ecosystem that accomplishes all three of those objectives while you are growing a crop, whether it's a corn or soybean crop, or whether it's stone fruit or tomatoes, it doesn't matter. So we need to be on the pathway to achieving each of those three goals. And there's this entire conversation of a decade ago that the buzzword was sustainable agriculture. And I made the point is, why would you desire to sustain where we are today? We have such a degraded ecosystem, we have such degraded soils. Why would we have any desire to sustain our present model of production? Instead, we first need to have a regenerative system that reaches a much higher plateau of performance, can achieve all these results, and then at that point, and only at that point, can we have a true conversation about sustainability. So I would say that this regenerative agriculture is regenerating the ecosystem on the pathway to true sustainability. And the metrics that I see for that are so broad, they encompass and cover everything else, are those three pieces. Achieving disease and insect resistance so you can be sustainable, no longer dependent on pesticides. Achieving nutritious food that is food as medicine so you can sustain a healthy human and animal population. And third, regenerate soil health so you can sustain this agriculture ecosystem for millennia.
I do have a couple more questions / topics that I would like for you to kind of do a deep dive, John. I'll start with the topic of carbon formation / carbon cycling. I'd like to talk about the effect of temperature during the formation of carbon, and then also how the end result or the end product of that, the difference in the carbon formation based on the difference in temperature, affects the crop that's going to be growing there next year.
Okay, so you used the word managing or influencing the formation of carbon in the soil. I'm assuming you're referring to the formation of humic substances specifically, rather than just generic carbon. So I'll try to condense this down into a few sentences. We know that humic substances in the soil are generally categorized as either fulvic acids, humic acids, and humin. And actually, I spoke incorrectly. These are not the characterizations of humic substances in soil, but more of humic substances in mined humic salts, linardite, etc., and dry humates, or lignite, or whatever accepted terminology might be at the moment. So within the soil, when we have high temperature environments or high temperature soils greater than 60 degrees or even greater than 55 degrees Fahrenheit, as biology and fungi consume organic residues and lipids and everything else and convert them to humic substances, when soil temperatures are warmer, the majority of the humic substances produced are in the form of fulvic acids, what we think of as fulvic acids. They are lower molecular weight compounds. They're very active. They're very strong chelation agents. When soil temperatures are cold, below 55 degrees Fahrenheit and perhaps even colder or frozen, soil microbial activity never completely stops, but it slows down, as does molecular activity and atomic activity. And as a result of this slowing down in colder temperatures, we form much higher concentrations of the more complex humic substances, such as humic acids. So these are much longer chain, more complex molecules that generally tend to degrade much slower. They have some slightly different properties and activities in the soil profile. And so the simplest way to think about this is to actually look at the various humulite or linardite deposits in the northern hemisphere and see how they shift. So as an example, The deposits in the Dakotas and in Alberta have a very high proportion of humic acid and a very low proportion of fulvic acid because they were formed in a very cold temperature environment. The deposits in New Mexico in the desert have very high proportion of fulvic acid and a comparatively low proportion of humic acid. The ratios are completely different, north versus south, and you see this gradual progression north versus south. That is primarily an effect of temperature. The same process holds true in soils. Why this matters and why we should care is if we want to build soil organic matter and if we want to build humic acid as the component of humic substances that remains viable in the soil for a very long period of time, then we should desire to have our microbial decomposition and the formation of humic substances happen in colder soils, so during the winter months. If we live in an environment where this is not possible and our soils never go below 55 degrees Fahrenheit, then this is one of the reasons why we need to accept the reality of the situation that we are never going to have quote unquote high organic matter content soils. We can still have soils with very high concentrations of microbially active carbon, but we're not going to have high organic matter soils in these environments because the temperatures are not low enough to accumulate stable humic substances that last for very long periods of time, hundreds of years.
So that answers the question on the formation very well. Now, what would you expect the differences to be if there's more carbon formation? Let's say on the same farm, you introduce and support and stimulate microbial activity in the fall to accelerate or to build a larger volume of the carbon during the winter compared to when you do that in spring and now you plant the same crop. What would you expect the differences to be in the crop's performance?
Well, it also depends, David, on the stage at which you terminate and incorporate that crop. So we have to consider that as well. So if we incorporate a crop, I would even suggest that that is the primary, that's the primary determination of the effect that you'll have on the following crop. So if you incorporate a mature crop that has a very broad carbon to nitrogen ratio, which is going to be primarily digested by fungi, with that broad to carbon to nitrogen ratio, you will build these stable humic substances and you'll build organic matter. But you will deprive nutrients from the following crop, at least for a period of 6 to 8 weeks after that crop has been incorporated, because the biology eats first and they need nutrients to break down that crop residue. If, on the other hand, you incorporate a cover crop that is immature and has a very narrow nitrogen to carbon ratio, that is primarily a bacterial food source, and that bacterial food source will not produce stable humic substances. You will not build soil organic matter with it, but you will provide a flush of plant available nutrients within 2 to 3 weeks after incorporation. So to go back to what I was speaking about a moment ago, if you want to build humic substances in the soil as efficiently and effectively as possible, the magical combination would be to incorporate either crop residue or a mature cover crop in the fall as soil temperatures begin dropping. That's how you're going to build humic substances in the soil the fastest.
I'd like for you to talk about the nitrogen to sulfur ratio and the level of sulfur within the carbon or within the soil and how that affects the organic matter level and the importance of sulfur in that carbon formation. And are there any other key minerals that are needed for this carbon formation that maybe aren't generally talked about in mainstream agronomy?
Yeah, so to your first question, there's a biochemistry perspective and a chemistry perspective. From a biochemistry perspective, we could speak about the importance of lipids that are needed for the formation of stable humic substances. But if we just simply speak about it from a chemistry perspective, we know that when we have stable soil carbon, stable soil organic matter, this stable organic matter will have a carbon to nitrogen ratio of approximately 30 to 1. So that means that if we want to sequester 3,000 pounds of carbon in our soil profile, then the crop residue and fungi and the minerals of the soil are coming from the atmosphere. We need somewhere in the nitrogen cycle to contribute 100 pounds of nitrogen. So In order to have a 30-to-1 ratio, if we have 3,000 pounds of carbon, we need 100 pounds of nitrogen to stabilize that. Then we also understand that in order for that nitrogen to be stable, we need to include all of the amino acids that are the stop amino acids in order to keep the proteins stable and prevent them from degrading further. So these stop amino acids are the sulfur-bearing amino acids, cysteine and methionine. So in order to keep the nitrogen stable, we need to have a 10-to-1 nitrogen to sulfur ratio. So if we have 3,000 pounds of carbon that requires 100 pounds of nitrogen to remain stable, that means that to keep the 100 pounds of nitrogen stable, we need to have at least 10 pounds of sulfur in the soil profile. And so what we've observed happen is that the key descriptive term that I've been using in these sentences is stable. What is required to keep the carbon stable? What is required to keep the nitrogen stable? And what happens is when we have soils that don't have adequate sulfur, then essentially this ratio, these three elements, nitrogen, carbon, and sulfur, will continue to be metabolized in the soil until they reach the lowest common denominator for stability. So if carbon or nitrogen or sulfur, it can be any of those three could be the lowest, but most commonly we observe sulfur to be the lowest. So if you have 3,000 pounds of carbon and 100 pounds of nitrogen, you need 10 pounds of sulfur. What happens when you only have 5 pounds of sulfur? When you only have 5 pounds of sulfur, now you can only stabilize 50 pounds of nitrogen instead of 100. So the nitrogen level drops to 50 pounds, and the carbon level drops from 3,000 to 1,500 pounds. And all that additional carbon, the great majority of it, will be volatilized and lost into the atmosphere as CO2 and off-gassed. So you've lost a lot of potential organic matter. You've lost a lot of carbon because you didn't have enough sulfur in the ecosystem.
Interesting how we hear somebody talk about sulfur and then we go and we address sulfur and we forget about calcium, and then next year we might hear about calcium. So we apply calcium and forget about sulfur. Yeah,
and so I think that speaks to your second question of what other minerals are important. You can think of it almost as being the concentric rings on a target, on a bullseye. Yes, managing sulfur and nitrogen carbon ratios is critical for this specific aspect. But then if you want to support the microbial population, so that is a part of this entire process, and then plant health and all that contributes to that, then of course those rings just keep expanding and expanding until ultimately, when you go to the outer edges, you include all the 64 elements that are known to be beneficial to living processes and to enzyme structures and so forth.
I've been really working a lot with soil-borne diseases, and I'd like for you to talk about presence versus expression, because if I'm understanding this correctly, there's a very few soils who don't have the presence of pretty much every pathogen, but they're not expressed everywhere. Why? And what are some of the key factors?
It is my understanding, based on doing a lot of research, reading hundreds of peer-reviewed published papers on this topic, that there is very little correlation between the presence of a disease-causing organism in the soil and the infection of a plant or a crop with that disease. So instead, the question is, what is the correlation? So why, let's just pick on Phytophthora, or Verticillium, or Fusarium, or Pythium. You could pick any of those as an example and say that the presence of the organism is essentially ubiquitous. It is in soils throughout our agricultural production systems. And the only difference between those soils where it causes an infection and those soils where it does not is not just in the cultivar and the variety, whether it's susceptible or not, although that can have an effect. But the biggest contribution, the biggest reason is the other organisms that are present. It's the environment. It's the remainder of the soil microbiome that suppresses the potential pathogens and either prevents them from infecting the plant or permits them to infect the plant. So if we want to develop soils that are called disease suppressive soils that can prevent the infection of these diseases, it's not a question of planting disease resistant varieties. It's not a question of growing a crop rotation that doesn't offer a host to the pathogen. It's simply a question of changing the soil's biology, changing the soil's microbiome. And when we change the microbiome, we can develop a disease suppressive soil that will prevent the infection of a plant, even when we plant a susceptible cultivar, even when we have a crop rotation that is considered to foster the hosting and the development of that specific organism.
So what I hear you saying is to build the microbiome in such a way that these soil-borne diseases aren't able to proliferate.
Exactly. According to Don Huber, I don't recall if this was in a personal conversation or in one of the podcast interviews that I did with him, but he was very clear that when you have two fields, one field has a Fusarium infection, the other one does not, there is no difference in the population of infectious Fusarium in the field. The quantity, the concentrations of Fusarium organisms in each gram of soil are identical. It's not the presence or the absence of Fusarium that causes the disease. It's the presence or absence of other organisms that causes the expression of the disease.
So with that, I mean, looking at something like Alternaria, for example, where Alternaria on a tomato leaf is a beneficial. It has a symbiotic relationship with the tomato plant. And my understanding is that Alternaria is in fact a very strong antagonist against mildews, which is why tomatoes are not as susceptible to mildews as maybe cucurbits are. But when people normally think of Alternaria, they think of the little spots and they think of the disease. So what happened there? Alternaria was beneficial, and now suddenly we need to kill Alternaria, or we call Alternaria a disease. So taking that as an example and a context, is that also happening in the soil-borne diseases that we're talking about?
Yes, it's very similar to what is happening in the soil. So Alternaria solani, the organism that you're referring to, is known to be present on the leaves of essentially all of the solanaceous plants, so tomatoes, peppers, potatoes, eggplant, etc., from the moment of germination. So the moment that seedling germinates, there are already Alternaria solani on the leaf surface, and they colonize that leaf surface throughout the plant's entire life. And it is only when their relationship with the plant changes because of the state of the plant's health or unhealth, which we call dis-ease, that later in life, when the plant is under stress, the Alternaria solani begins attacking the plant. It doesn't happen at the beginning. Why not? Because the plant is not susceptible to it, and the plant is actually feeding it. It has a symbiotic relationship with it. So yes, the same type of symbiotic relationship is present with soil microorganisms that prevent the infection of soil-borne diseases.
Fusarium, Phytophthora, verticillium, the things that we call diseases, are they also a beneficial that then in turn attack the plant?
I don't know if this is true for some of the seeds and for all the organisms like Phytophthora we spoke about a moment ago, but my understanding is that is the case for some of these organisms such as verticillium and Fusarium, where they're actually saprophytic fungi. They're decomposers. They decompose non-living plant residues. So if you put hay or straw mulch out and it rains on it a couple times and then you pull it up and you see this white mycelium going all the way through it, majority of that white mycelium in many soils will be verticillium, functioning as a decomposer. So again, it's not the presence of the organism that produces an infection, it's the presence and a symbiotic relationship with other organisms.
Dead plant material digesters, and they're eating the plants that are supposed to be producing our food? That's a scary comment.
Maybe it perceives those plants as being dead.
That's okay. In context of that, we have one question here from David. Do you see a benefit in testing the soil for biology, such as bacteria and fungal groups and levels?
David, I would love to say yes. And I'll speak in the context of our experience at AEA. There may be people who have figured this out. We have looked, and I personally have looked at a lot of different types of assays and laboratory testing, and we're not at a point yet where we are doing any of that laboratory work. And primarily because we haven't figured out how to make management decisions from the information that it provides. So we know from a very high level, these are the management practices and the cultural practices, growing cover crops, diverse crop species, et cetera, et cetera. These are the things that we need to do to develop soil biology. And we're going to do those things and make recommendations for those practices, regardless of what a lab report on a piece of paper says. So how do you manage differently for bacterial populations, fungal populations? There are a lot of theoretical conversations and some limited practical application, but we haven't seen that practical application actually make a difference on scale on very many farms. So maybe that's simply only because we haven't figured it out yet, and maybe it's because collectively many of us haven't figured it out yet. So that's kind of the best answer I have to offer for the moment.
So the next question for you, John, is I like the concept of regenerative agriculture, but with land rents very high on coastal area of California, how can we incorporate these concepts into a strawberry cropping system where the soils are fumigated and there is intense pressure to produce large amounts of fruit through the season? I like the noble concept, but I struggle with how to implement something like this in high value cropping systems. What are your thoughts?
Yes, correct. A very challenging environment, and you can implement regenerative farming systems. We've already done it. So it is a challenged environment, absolutely, but it is possible to post fumigation, to re-inoculate biology and to supply other food sources. And in the work that we have done on strawberry production in California, we've been able to see, going from memory, I believe in some of the trials we conducted, we were able to see as much as a 13% yield increase. So from my perspective, this is not just simply a noble concept, it is straight, pure economics. We can help you be more successful, make more money, be more profitable using these regenerative farming systems than the chemistry systems that are presently the mainstream.
Thank you. And a question, John, I have a question on pests that attack fruit, such as fruit flies. There are some insects that attack the actual fruit instead of the leaves on an apple or a cherry tree, for example. You mentioned your formula in the past, which is a combination of magnesium, sulfur, molybdenum, boron, molasses, so forth, and the effects on most, and that it is effective on most pests. Do you have suggestions for controlling the fruit type of pests?
This is a very good question, and the answer is that it is actually the same solution and the same remedy for these pests that infect fruit, but there's one significant difference. In addition to that formula, the fruit and the seeds of the fruit have the highest mineral concentration requirements of any part in the plant. And for example, the zinc and manganese and boron concentrations in the seeds or in the fruit are often as much as 60 to 80 times higher than they are in the leaves. And because of this reason, the fruit are often the weakest part of the plant, meaning they're the most susceptible and that they are the last to become resistant. So keep going down the pathway that you're already on, pay close attention to these trace minerals, and you will see crops that develop resistance to spotted-winged Drosophila and fruit flies, etc., exactly the same that they've developed resistance to insects that infest the leaves. It's simply going to take slightly longer and going to take more time for you to get to that point, but it is equally achievable.
One more quick question from our guest. Can regenerative agriculture coexist with trees and hedges that pre-exist in the environment, or do the trees suck all the water and nutrients out of the soil?
I would say the short answer is yes, absolutely. Regenerative agriculture benefits from trees and hedges in the environment.
And I would agree with that. Many times we think of it as taking nutrients, but I think we often underestimate the value of these other crops and the crop symbiosis that happens between different crops. So you have a deep-rooted tree and brings up nutrients. It's great. All right, John, I'd like to ask you two more on the personal side questions, if you will. Did you remember in your life?
Goodness. Well, definitely one of the happiest days of my life was the day that I got married. And for enjoyable moments, I would answer it was the moment I got married if my heart hadn't been racing quite as fast as it was. So there have been many enjoyable moments, David. I've been very privileged to work with some really great people on our team, yourself included, and with our growers. I really enjoy being out in the field, with our consulting team, with our farmers, and seeing what's happening and what's going on. So I really do have a lot of fun every day. I don't have to work, and I love that.
All right. And for the final question for you, John, what habit have you developed that has had the greatest positive impact on your life?
That's a good question, David. And I would say the one habit that I've consciously tried to develop that has had a significant impact, and actually I think cannot be underestimated, is the ability to observe. I heard this when I was first learning and studying plant nutrition and agronomy. Kerry Reams and Dan Scow would just, and as well as Arden Anderson, would just constantly repeat this phrase: see what you look at, see what you look at. And I just got that hammered into my head. So there is this phrase that some people can't see the forest for the trees. And so occasionally I've heard people make the comment that stop paying attention to the forest and look at the trees. And I would suggest that is not even enough for the work that we need to do in developing these agriculture ecosystems. We need to start paying attention to the leaves. So pay attention to what you see and what is missing. As you gain some experience, you start noticing the things that are missing. So one of the things, I'll just give you an example of something that I observed that is an observation. It can be more challenging to observe what is missing than what is present, because it requires experience, of course, to know what is missing, and that requires a history of observation. So on a personal note, for us this last fall, we normally have katydids. And the rule of thumb here in Northeast Ohio is that we will have the first frost approximately 90 days after the first katydid. And the katydids sing pretty much all the way through until frost, or at least within a couple of weeks of. And something that I observed this year is that the katydids were here for about 6 weeks, and then they disappeared. There have been no katydids calling for the last, pretty much the last 6 weeks since the middle of August. So where did they go? What happened? So I think just the one habit that I've tried to cultivate is observing the details of what's happening and what's going on in the environment around me. That has been incredibly rewarding.
Very good.
David, I saw 2 questions that I would like to respond to briefly. There was one question that came through is, when do I think that the consumers will be able to measure the nutritional value of their food on the grocery store shelf? I believe that'll be happening in about 24 to 36 months, and I have good reasons for saying that. So that's something that'll be coming in the relatively near future, I believe. And then there's another question here from Jeff McInnes that I think is important to answer. How can regenerative agriculture contribute to carbon sequestration? And can we actually help to change the amount of CO2 in the atmosphere? Can farmers actually be the answer using regenerative agriculture? This is an important and valuable question. Thank you for asking it, Jeff. I actually did the math on this question, looking at the farmland that is available globally. And this is farmed tilled soil, or I shouldn't say tilled in the case of no-till, but actual farmed soil with annual or perennial crops, not including rangeland and not including grazing land, just the farmed soil globally. If we were to generate or sequester carbon, sequester organic matter at a conservative rate, based on what we've observed in the farms that we've worked with, of a 1/4 percentage point of organic matter gain per year, we could sequester carbon at a rate of 13 part per million CO2 out of the atmosphere annually. So we could actually go back to pre-1970s level in as little as 13 years. And of course, we know that rangelands and grazing land, when properly managed with intensively managed rotational grazing, holistically managed grazing, can actually sequester carbon faster than the tilled soil and the farmed soil, and there is more of it. So I believe that the answer is absolutely yes. Regenerative agriculture can be the answer to sequestering CO2 and restoring our hydrological water cycles and so forth. So it's a very good question. Thank you, Jeff.
So regenerative agriculture aside, if we, even using conventional practices, just having the soil covered, would we be able to do what percent of that?
Haven't done that math, so I don't know, but you could, you'd have to do a combination of different things. Obviously, we have to stop burning it off with tillage and nitrogen applications. That's part one. Part two is we have to keep the soil covered with living, growing plants all the time to capture that. So if you simply put all the farmed acres into cover crops and you reduce tillage and reduce synthetic nitrogen applications, if you did those three things, you would probably have 70 to 80% of the total effects.
Okay, again, thank you, everyone. Thank you, John. You'll have a wonderful day.